Let's look at how vectors work with some arithmetic. So this is telling us that we have the vector 3 minus 2. Let's just draw that on. So 3 across, 2 down. So that vector there. And then we want to add on this vector here. So let's just change colour for this one. So we'll write this as 4, 5. That's telling us that from where this vector ended, we then add 4 and then add 5. So we should end up here. Well, what single vector would achieve that same movement? We can simply add the total distance that we moved across. So looking at this, we had 4 across and 3 across. So we're going to get the answer 7 across. And then we're also going to have 2 down. So we had 2 down. And then we had 5 up. Overall, that's a net gain of 3 up. So for this, we can see what we would do. We would just add the tops and then add the bottoms. That would also work if we wrote this in I and j form. What we would have is 3i minus 2j plus, let's change to red so we know it's corresponding to the same vector, 4i plus 5j, remembering to underline anything that's a vector. All that we do now is we collect our I terms, so 7i, and then collect our j terms, just as if we were doing algebra, and we have minus 2 plus 5 plus 3j. Exactly the same answer, just 2 different forms. You'll need to be comfortable working with both forms, as questions will be posed using both of these forms. What else can we do with them? Well, we can multiply vectors by a scalar. A scalar is something which is not a vector. For example, 3, lots of 2 and 5. That is going to be exactly the same as 6, 15. We're saying we've got 3 lots of this vector, so if I've gone 2 across, 5 up, 2 across, 5 up, 2 across, 5 up, I've done exactly the same thing 3 times. I'm just going to end up with 6 across, 15 up. Okay, so multiplication and addition are as easy as we would expect. Only thing that we can't do yet, we can't multiply 2 vectors together, so we don't yet know how to do this. A dot means multiply, and in fact we can use a cross for multiply. If you're doing further maths, you will learn how to do this, but we don't need to worry about that in regular maths. One final thing, let's say that we wanted to find an angle between, say, this vector and I. So remember, I is just the horizontal. This vector goes 2 across and 5 up. Across, 5 up. If I want the angle that it forms to the angle I, to the vector I, I need that angle there, and we can see I've got a right angled triangle again. Opposite and adjacent, I would need tan inverse of 5 over 2, inverse tan, 5 divided by 2, 68.2 degrees. Okay, so we can add vectors, multiply them by a scalar, and find the angle between them and another vector. You may, if you have a more complicated situation such as the angle between 2 different vectors, you would have to use some of the trigonometry we've learnt earlier. If you do further maths, there are other techniques. We'll stick with the trigonometry for now.